Hello and welcome to Tvaritam.AI. In this video, we are going to understand outlier handling. Outliers are data points that significantly deviate from the general distribution of the data. For example, if most values in a dataset fall between the range of 10 and 50, then extreme values like 175 or -20 would be considered outliers. When it comes to type of outliers, these are of two types: invalid outliers. Invalid outliers are error values that may appear due to data entry mistakes, system glitches, or faulty sensor readings. They should not exist in the data in the first place. For example, negative values for age or salary column, temperature recorded as 50 degrees Celsius for body. These violate known physical or logical limits, making them clearly invalid. Now, second category is of valid outliers. These are genuine data points that deviate significantly from the center of the distribution but are not incorrect. For example, upper management salaries being far above the median employee salary, luxury car prices well above the typical $50,000 to $150,000 range, and temperature of Antarctica as compared to the global average is very low. So these are valid outliers which are significantly deviating from the distribution but are not incorrect. Now, why these outliers are important? Because these can distort model training. Large extreme values can dominate or stretch model parameters. For instance, a few very high salaries can inflate the average, causing the model to believe the typical salary is much higher than what it actually is. So we have to detect the outliers and then we have to take actions. To detect the outliers, first method is to have a custom threshold. It is best used when you have domain knowledge about the valid limits. Like age cannot be negative, so we can set a lower bound to 0. Body temperature cannot exceed something close to 40 to 43 degrees Celsius, so we can set an upper cap. Or temperature in Kelvin cannot physically go beyond 0 Kelvin. Second is our standard deviation method. Now, standard deviation method is best suited for normally distributed data. This is called Gaussian distribution or bell curve distribution also, as reflected on the graph on the bottom right. This is a perfectly normal distribution. In real world data, it would not be as perfect, but if the distribution looks similar to a bell curve, we call it a normal distribution. The formula to detect outliers is mean plus minus x times standard deviation. We can keep the value of x as 3 for being a more lenient value and x is equal to 2 for more strict outlier detection. But again, this method is sensitive to extreme outliers since it relies on the mean, which can itself be skewed. Now, the third method is interquartile range method. It is best suited for skewed data where the mean is unreliable due to large number of outliers or extreme outliers. In this case, we calculate IQR, that is Q3 minus Q1, and the formula is Q1 minus X times IQR for the lower threshold and Q3 plus X times IQR for the upper threshold. Values can be 1.5 for more stricter outlier detection, which is the standard, and X could be 3 if we want to keep it lenient. Now, if you want to understand a little bit more about IQR, this is what you see on the graph. Now, to understand this, in the chart, you see Q1 is equal to 42.8. This is the 25th percentile, that is our Q1. So 25% of all data points fall below this value. As you see, Q3 here is close to 54.9 and this is the 75th percentile, and 75% of all data points fall below this value. Now, IQR or interquartile range is the difference between Q3 and Q1, that is 54.9 minus 42.8, which is equal to 12.1 in this case. This is the range that contains the middle 50% of your data highlighted in the blue on the chart. Now here median is 48.5, which is the midpoint of the data shown by the vertical line inside the blue region. The data points that fall outside the whiskers on either side, that is beyond Q1 minus 1.5 into IQR on the left and Q3 plus 1.5 into IQR on the right, are your outliers. The key insight here is that IQR focuses entirely on the middle 50% of the data. It completely ignores the extreme ends, which is exactly why it is not affected by outliers the way the mean and standard deviation are. Now, techniques to handle outliers: first is to remove or drop them. We can delete the outlier row entirely, but this should be done with caution because dropping the row can cause information loss on other columns also. So if you drop a row and you have other columns with valid values, you are actually losing data that you might not want to lose. So if there are very few rows, like 5 out of 10,000 or something, then dropping can make sense. Second is to replace with null. So we can mark the outliers as null values and impute it later using the imputation methods. So if we are not sure about the outlier and we want to preserve the record count, then we can go with replace with null, and then we can follow up with the missing values. Then we have capping or clamping at threshold. Now for capping and clamping and threshold, what we do is we set a ceiling or floor value. Any value beyond the threshold is replaced with the given threshold that we have. So if there are many extreme values and we want to retain the context, we clamp it at a certain value. For example, if all transaction amounts above $100,000 are clamped at $100,000, the model still knows that these are high value transactions, but they won't distort training as much as the actual value might. Now moving forward with the implementation part, here you can see the walkthrough of how you can get rid of outliers or you can detect them and take an action. So in the transform continuous features tab, I have all the continuous features, and first one that I want to work on is age. Now we can see there is a negative value present in the age column. So this is very straightforward. I will just select a lower bound for age as the X value, and the value of X here would be 0, or you can also give 18 or 15 in case you are only dealing with adult people, right? So we will drop this value because we only have a single row. Now second is income column, right? Now going towards the income column, what we can see here is that the distribution is close to normal with some significant outliers on left and little outliers on right. Now here what we can do is, first we know negative income is not a correct value. So I can create a lower bound here also as 0 and either drop the data points or clamp at threshold. Here let us just drop the data points. We can also replace with null. But if I drop the data points here, the distribution itself will change a little, and now we see that these outliers are not that much to work upon. So distribution also is affected by invalid outliers. The first step should always be to remove invalid outliers and then see if the distribution still has outliers or not. Then we have credit score. So let us move forward, and what we can see here again is that there is this one very significant value that is harming us. So we know that there are certain limits to credit score. It cannot be more than 900. So you can just create 900 as your domain based limit, and we can drop that data point also. Now we can see that now distribution looks much better. And lastly, we will do account balance. Here we see that data is highly skewed and negative values could still exist in account balance. Maybe someone has an overdraft, someone has taken more money out of their bank account that they have, and you can get some negative balance. Assuming this, we don't want to drop them. So what we can do here is we can use IQR method on both the range. So I will go Q3 plus X times IQR for upper bound, Q1 minus X for lower bound, and let us give the value as 1.5. And here we will, instead of dropping, clamp at the threshold. Now I click on apply and distribution changes. And this is how we can detect outliers, and we can also deal with them before moving forward with our machine learning. Thank you.